Yo, what's up, guys? Welcome back. I think episode 126 today. Man, I needed to quench my thirst. Oh my gosh. So yeah. The last time I made a video was Friday. It's been Memorial Weekend today, so today's Monday. It's just the evening. Had a great weekend with my girlfriend. We're gonna be back at it, making another video today. So yeah, I have to go play pickleball at 6:30, so this is not going to be a very long video, probably about 30 minutes, 40 minutes, but tomorrow we'll have another regular 2-hour video. I'm thinking about doing some different things. I have a few ideas, like, again, if you're watching this, like, there's not many people that, watch my channel or watch the videos I create. To be honest, they are pretty boring. Not gonna lie. But I'm kind of maybe trying to think of ways to make them more entertaining. Maybe shorter videos. Maybe different ways. Instead of me just like kind of like raw problem solving. Maybe like me talking about the problem. I don't know. Like, I also thought about live streaming. I've thought about different things of how I can kind of make like the content a little bit more engaging. Maybe to kind of actually attract some people that watch, because I think there's only maybe a very small amount of people that actually probably watch more than a minute of the video. So, I don't know. I'm going to be brainstorming a little bit. I'm hoping to change up the content maybe a little bit more, but I don't know. We'll see. But, when I started this series, like, it wasn't really about like, gaining views or like getting people that actually watch. Like, to be honest, I really don't really care that much. It was more about like the documentation and like keeping me, coming back every day and like recording problems. I just really enjoy the satisfaction of seeing like the amount of videos go up and me being at episode 126 today, or like 250 or whatever. And I just want to keep going, just see where it can take me. And I generally really do enjoy it. Like, I enjoy the problem solving, I enjoy learning. So, at the end of the day, I am learning something, and it's good for me. So, yeah. That being said, let's jump into episode 126. We got a magma today. Let's check out the sound. Check out this 3-second video. You can see I have not been on my computer. I got 9+ notifications. Just a bunch of crap though. It's okay though. Oh, whoops! Didn't mean to do that. There we go. Yeah. That's what we got today. Last Friday we did a graph problem, and honestly, I couldn't solve it in the 20 minutes I had. So maybe we try and find something that's a little bit easier. Let's see what daily problems we did miss. Longest palindrome by concatenating 2-letter words. I think this was the one from Friday that we looked at. I think. Because we tried this one. That was Thursday. This is Friday. And this is Saturday. Let's take a look at this problem. It's got a 9% acceptance rate. Should be a pretty quick problem, I think. Hopefully. You're given a zero index array of strings, words, and a character X. Return an array of indices representing the words that contain the character X. Note that the returned array may be in any order. E occurs in both words leet and code. Hence, we return indices 0 and 1. Okay. Okay, so we literally just loop through and we just check if they're this should be a pretty straightforward problem. Let's do, for word in words, right? Let's print our word, right? This should print what we're looking at here. Okay. Right, so we got Leetcode, right? So then what we want to do is we want to do another double for loop here. And we go for I in words. Let's print I. I'll go for the in word. Oops. Meant to be in word. Okay. So we got each one, right? Let's have like some sort of flag, right? So let's have like a flag is equal to false, right? Let's say if I is equal to X, the flag is equal to true, right? Okay. We're gonna leave a print I here, right? And let's say at the end of this for loop, we get through and we can check, well, if flag is equal to true, then we do res.append what we're gonna need the indice here, so let's do for word in range length words. Okay. Res.append word. Let's do words word. Oh, sorry, we want the indice, which would just be word, right? And then we would return our res. We need to define our res here. Let's do that. Let's see. We have to change this up. I think for I in range length word, if word I is equal to X, make the flag true, and we append word. Let's see what that gives us. Has no length. Let's do the length of word. Sorry, words. Word? Is that how it would work? If actually, wait. Let me just copy this. All right. Let's paste it in here. Let's fix this ourselves, right? We can do a double for loop here where we can go for index in word in enumerate words. Okay. We can do for I in range. For I in word, if I is equal to X print I, we would append our word. We want to append the index instead. Maybe this should work. Yeah, at least we return something, so that's good. Okay, so how are we appending 1 and 3 here? Oh, we need to make our flag false then. Flag is equal to false for the next iteration. Will that work? I'll go. I guess you could do it like that. Fair enough. See, mine's probably slow. Yeah, I don't know. Probably could have done a faster solution, but it's alright. Oh, I got this bag away from me, bro. Putting in too much calories, dude. Oops. That's my email, bro. Alright, about half an hour left. Let's take a look at longest palindrome run by concatenating 2 strings. There's a little bit of a harder problem. You're given an array of strings words. Each element consists of 2 lowercase English letters. Create the longest possible palindrome by selecting some elements from words and concatenating them in any order. A palindrome is a string that reads the same forwards and backwards. This is definitely a tough one. This is a tough problem. I mean, obviously, I know how to find a palindrome and a number. I mean, just 2 pointers and going all the way to the middle till they cross. I know that, but in terms of hash table string greedy counting, alright, I always struggle with how we can pick. Man, it sucks that Leetcode doesn't make any videos anymore, man. Like, really, really sucks.
Hi there, welcome. Today we're tackling a Leetcode problem called longest palindrome by concatenating 2-letter words. It sounds a bit like a tongue twister, but don't worry, we'll break it down into simple pieces. Our goal is to build the longest possible palindrome, using a given list of 2-letter words. So what's the task? We're given an array of strings, and each string, or word, is exactly 2 letters long. We need to pick some of these words, arrange them in any order we like, and stick them together to make the longest possible palindrome. Each word from the input list can be used at most once. If we can't make any palindrome at all, we should return a length of 0. And remember, a palindrome is just a string that reads the same forwards and backward. Let's look at an example. Suppose our words are and, we can take put in the middle, and then at the end. This forms, if you read that backwards, it's still so it's a palindrome. The length is 2 plus 2 plus 2, which is 6. That's the longest we can make here. Okay, how might we approach this? The first thing that pops into my head, often the brute force way, is to try every possible combination of the words we're given. Then for each combination, we'd check if it forms a palindrome. But imagine if we have 100 words. The number of combinations would be absolutely massive. That's going to be far too slow. We probably need a smarter strategy. Let's think about the structure of a palindrome. It's symmetric, right? If we have on one side, we need its reverse on the other side to match. So counting how many times each word appears seems like a good first step. We can use a hash map, or a counter, for this. So the core idea is this. First, let's look for words that are not palindromes themselves, like, we need to find its reverse, which is, if we have, say, 3 and 2, we can make 2 pairs. Each such pair adds 4 to our total palindrome length. Next, we look at words that are palindromes, like, if we have, say, 4, we can make 2 pairs, on one side and on the other. That's 4 used, contributing 8 to the length. If we had 5, we'd use 4 like that, and the one left over could be placed right in the middle of our big palindrome, adding another 2 to the length. We can only have one such centerpiece. Alright, here's the Python code that puts this strategy into action. It might look like a bit at first glance, but no worries. We'll walk through the important parts nice and slow, explaining what each piece does in plain English. First up, we use something called collections.counter on our input list of words. This is just a really handy way to quickly count how many times each unique word appears. For example, if words is counts would tell us we have 2 and 1. We also initialize our length to 0, and a little flag called center underscore found to false. This flag will help us remember if we found a single 2-letter palindrome, like that can sit in the very middle of our big palindrome. Next we loop through each unique word and its count underscore W, how many times it appeared, that we got from our counter. First, we check if the word is a palindrome itself, meaning its first letter is the same as its second letter, like, or. If it is, we see how many pairs of this word we can make. For instance, if we have 5, the count is 5. 5 divided by 2, integer division, gives us 2, so we can make 2 pairs of each pair on the left, on the right, adds 4 to our total length. So, we add 2 times 4, which is 8, to our length. Then, if the count of this word was odd, like 5, it means we have 1 left over. This leftover 1 can be our centerpiece. So, we set our center underscore found flag to true. Now what if the word is not a palindrome, like its first and second letters are different? First we figure out its reverse. If the word is rev, underscore word becomes to make sure we don't count pairs twice, like counting, and then again we use a little trick. We only process the pair if the original word is lexicographically smaller than its rev underscore word. For example, comes before alphabetically, so we'd process this pair when we see. When we later see this condition will be false, and we'll skip it, because we've already handled it. If the rev underscore word actually exists in our counts, we find out how many pairs we can make. It's the minimum of the count of the current word, and the count of its rev underscore word. Each of these pairs adds 4 to our length. Finally, after we've gone through all the unique words, we check our center underscore found flag. If it's true, it means we found at least one palindromic word, like that had an odd count, leaving 1 spare. This spare word can form the very center of our palindrome, adding its length, which is 2, to our total length.
Let's get my email out of here, dude. Jeez. Let's take a look. I miss Leetcode, dude. When he stopped making videos, I just realized like how goated his videos are. Like compared to the others just like they just like that video, bro. Like didn't like barely spoke about the intuition, like Whereas Leetcode always speaks about that, which is the good part about it. Man, those snacks are looking at me again, dude. Okay. I want to take a look at the brute force solution, right? So we create our n here, the length of words, yeah. We create a use array, which keeps track of false times n. This will keep track of which ones we've used, right? And then we have our max length. I hate snake case, dude. I just like camel case is equal to 0. And then we have center use, which is equal to false, right? So here we loop through everything, right? For I in range n, right? We loop through all our words, okay? We check if used I, right? We would continue, right? If it's true, if we've used it, we don't need it, right? We would continue to the next iteration. For j in range I plus 1, n. We want to check, well, if use j, we would continue. Again, we wouldn't need it. Then we check here, this is the main part of the loop here, is we check, well, if words I 0. So we're checking the first element, right? Right, the first element is equal to words j1. So we're comparing the first element here to the last element. And words I1 is equal to words j0. So then we're comparing j0, j1. So if they're the same, we know we can concatenate these and make it a palindrome, right? So then we would set used I is equal, used I is equal to true, use j is equal to true. And we would set our max length to be equal to plus or equal to 4, right? Because we can make 4 different two-letter words, right? Because that's the length. Okay. Okay, and then we would break, right? Otherwise, we would go, okay, well, for I in range n, if not use I, and words I 0 is equal to words I1. So we're just checking if they're the same, right? The same word that we're looking at. If L and if it's like LL, they're the same. We want to make used I is equal to true, and then we want to update our max length by 2, right? And then we would break. We would return our max length. Oops, we got a typo here. This is probably too slow. Well, time limit exceeded, right? So if we were to loop through this, how would we be able to make this faster, right? So we can take a look at can we make this faster? Use a greedy hash map counter approach. Count the occurrences of each word using collection cell counter for each word, if not the same, when reversed. A, B. Okay. Alright, so this was our brute force solution, right? I feel like we have to get back into it a little bit, you know? I feel like we probably could have solved this, but we don't have a lot of time. We get back into it slowly, right? So instead now, we use a counter, right? And we let's do, sorry, count is equal to counter words from collections import counter. Let's do our max length is equal to 0. Use center is equal to false. Alright. We didn't even use that in the last one. Right. So what we want to do here is, let's print out count, see what we're looking at here. C1, CL1, GG1. Okay, what was the way we do it for each word? If it's not the same when reversed, e.g. AB, try to pair it with its reverse, BA. Use as many matching pairs as possible. Okay, so we would go, alright, well, for I in, sorry, for word and then word count in count, okay, let's print our word, let's print our word count. Sorry, in enumerate. Jeez, man. No, we're not getting it. We would do word count. Sorry, wait. It's count.items. Print word count. Jeez, man, it's been a while. Print word count. Right? Okay, that's better. Right? And we'd want to check, well, if word how do we want to do it? Do we just want to use the reverse? Okay, right. So we would do, okay. Reversed word is equal to word. How did they do it? They did it slicing way. -1. We could have just used reversed, but I don't know, it's alright. Okay, we can do, well, if reversed word in count, then we can do, if word is not equal to reverse word, count.key. Can they be duplicated though? If word does not equal to reverse word. Why are we doing that? Add one central palindrome if available. And we need to check, well, if reverse word is in the count, we need to check what the count is, right? So we'd have to do, well, if why are we doing if it does not equal reversed word? I don't get that. Oh, wait, I think we're checking that because, okay, I think I understand, right? So we're checking that if reversed word, sorry, if word does not equal reversed word, right? We're checking that because if reversed word in count, okay, we're checking that because they could be GG, right? They could be the same. We don't want ones like that. We want ones that are different, right? So if reversed word in count now, then we add it. Pairs is equal to the min of count word count reversed word. Then we would do max length plus or equal to pairs times by 4, right? Because we have 2 pairs. Count word minus or equal to pairs count reverse word minus or equal to pairs. Okay. Else, right after the same, now we're looking at a word that is GG or EE or CC, right? What we do with that is we would instantly add that, right? So we would do, well, max length plus or equal to 2, right? Pairs is equal to I don't understand why they do this, but okay. We'll do pairs is equal to count. Okay, well, yeah, count word divide by 2, right? And we do max length plus or equal to pairs times 4. Count word minus or equal to pairs times 2. Okay. We'll probably check if any unused same letter word to put in the center. If word and count, if word 0 is equal to word 1 and word count is greater than 0. So we're looking for a center here now, right? Because every palindrome needs a center, right? So for word in count, we're looking at, okay, if word 0 is equal to word 1 and count word is greater than 0, max length plus or equal to 2, then we break. So if word 0 is equal to word 1, after all parent, check any unused same letter word to put in the center. Then we would return our max length. Interesting. Wanna rock your body, rock that body. Come on, rock that body, rock that body. Let's do print got here. As it goes. I'm confused why we kind of divide here as well. Two letters from one word. I get this, right? Pay can't win. Bye bye here. through this test case. No full pairs. Okay. All right. I think I understand. All right. Well, I gotta start getting ready. So I appreciate you guys watching, and we'll be back for a longer video tomorrow. So see you guys tomorrow.